Now, third normal form, what it says? For third normal form is all about transitive functional dependency. So if in the transitive functional dependency, the key or the candidate key is determining the non-key, and that thing we find using the transitivity inference rule or transitive functional dependency. So let's say if we have A determine B, let's say B determines C in a relation A, B, and C, if these are the two functional dependency. So with transitive functional dependency, we can find A determines C, right? Now, because here A is the key, right?
Yes, sir.
Here A will be the key. A can determine B. Now B can determine C. So A will be the key because A closure is equal to R. So if A is the key, and through the transitivity rule, we find out this. If A determines B, B determines C, we can say A determines C. So we find A determines C. But this A determines C is in the form of like key is, or you can say candidate key is determining some non-key. Then it will be an issue with third normal form. So third normal form says that your relation should be in first and second normal form, and there should not be any transitive functional dependency in the form of non-key is determined by any candidate key, or non-key is determined by any key attribute. So that is given by third normal form. Getting it?
So could you repeat it again?
Yes, I can repeat. So the first one will be in the third normal form, first normal form and second normal form should be achieved. Should be achieved. Next is there should not be any transitive dependency having non-prime attribute determined by any key attribute. Okay. Non-prime attribute, which is, let's say C, is a non-prime attribute. So which is a prime attribute here? Or the key is A, and non-prime attributes are B and C. If B is determined by A or C is determined by A, any of the cases we have to see whether they are getting from the transitivity rule. If they are getting that with the transitivity rule and this non-key is determined by some key attribute, then there will be the issue. There will be the problem in third normal form. So it says that there should not be any transitive dependency having non-prime attribute determined by any key attribute. Do you understand?
Yes, sir. Sir, if the case would have been that A determines B and A determines C, then it could have been in the third normal form, right?
A determine,
B and A determines C.
yes. So A determine B and A determine C. Here we are not getting any transitive functional dependency, right?
Right.
We are not getting any transitive dependency here.
Yes, sir.
But here we are getting it, and that too in this form. Candidate key is determining some non-key. So if we are getting in this form, it means that it is not in third normal form. Okay.
Yes, sir.
So what we do with this? What we do with this? If this is the question, then what we'll do? If it says that R is X, Y, and Z, where the functional dependencies given are X determined Y and Y determines Z, and we have to normalize up to third normal form. So what is the solution? Okay. So here the solution will be, the first of all, we have to find candidate key. Okay, so what is a candidate key here? If we'll find out X closure, it will be X, then X determine Y, then Y determines Z. We are getting R, right? So X is my candidate. Which one? X. Now, if X is the candidate key, the second part will be, we have to check for second normal form, because third normal form says that your relation should be in the first and the second normal form. So first normal, if you are not getting any data, it means that we are assuming that it is not having any sort of non-atomic data into the field. So we are assuming that it is in the first NF. For the second NF, what we have to check? We have to check for the functional dependency, X determine Y, Y determine Z. Because we are getting atomic value in the determinant part, both. In both, X determine Y and Y determines Z, there is no partial functional dependency, right? There is no partial functional dependency. Why? Because we got key as X and X could not be divided further, right? So if it will not be divided, how will find out the part of the key or the partial functional dependency? So it is in second normal form. Now let's check for third normal form. So if we are checking for the third normal form, so first we have to find it out any partial function, any transitive dependency. Do we have any transitive function dependency? Yes, we have X determines Z. X determine Y, Y determines Z. So we can say X determine Z. So X determines Z is a transitive functional dependency. Now the question arises, is this functional dependency satisfy third NF? Now the answer is no, because this is the key and this is the non-key that we are getting through partial, we are getting through transitivity rule, and we are getting this as a transitive functional dependency, and we are getting keys determining some non-key. If key is determining some non-key, it does not satisfy third enough. It does not satisfy third enough. So what we have to do, the R, which is X, Y, and Z, should be divided, should be split. Now, but because of which particular functional dependency we have to split, because of this. If this will not be there, we didn't get the transitive functional dependency. Because of this functional dependency, we are getting the problem. So we'll put YZ in one table and we'll put XY in another table. Now, for this, functional dependency is XY, and for this functional dependency is Y determines Z. So in this R1 table, X is the key, and for R2 table, Y will be the key. So if Y will be the key and we didn't get any other dependency, functional dependency, so we cannot find the transitive functional dependency. So now this R1 and R2 both are in third normal form. R is not in third normal form. So we have splitted the table into R1 and R2. Now R1 and R2 both are in third normal form. Any doubt?
So why did you put Y in both the tables?
It depends upon the dependency. See, if you will not put any common thing, how you can relate it later on? We have learned about the decomposition, right? So there is some
Yes.
rule in the decomposition like lossy and the lossless decomposition. In any of the decomposition, we have to bother about there should be some common attribute. Then only we can get the, or we can join them, right, to get our original one. So Y is the common attribute here. So if you'll not put Y in any of the table, then how you can join it later on?
Right. Got it, sir. Thank you.
Getting the problem?
Yes, sir.
So joining is the problem. That's why we are having some common attribute. Let's go for another question. X, Y, Z, W, and P. Functional dependencies we have is X determine Y, Y determines P, Z determine W. Okay. Now we have to solve it up to third normal form. So for that, first of all, what we have to do, find candidate key. So the finding the candidate key, use these. Let's find out the candidate key. X closure. Do we get X closure as a candidate key? X is determining Y. Y is determining P. That's all. Now what about Y closure? Y closure could be determining P only. What about Z closure? We are finding Z and W only, right? So let's calculate the closure of XZ. So we'll get X can determine Y can determine P, and we have Z can determine W. Now here when we got the candidate key as XZ. Now we'll start the process. Now, what is the second step right now?
Checking for second normal form.
So check for second normal form. Now let's check for second normal form. Part of the key, right, is determining anything. It means that it is not in the second normal form. So the functional dependency that we have, X determine Y, is satisfying? No, not satisfy second normal form. This is A. Is any other functional dependency? Y determine P. It is determined, yeah, because Y is not the key, right? So it's satisfied. Satisfy second normal form. Now let's say C, functional dependency. Z determines W. Z is a part of the key which is determining some non-key. It means that it is not satisfied second normal form. So two functional dependencies are not satisfying the second normal form. Then what we have to do?
We'll divide it in three parts.
Let's make it R. R is X, Y, Z, W, and P. So, which is giving the problem. So we have XY, which is creating the problem. So X, Y, and P, we can write it at once. Because X, Y, P is not creating problem, okay? So we can put that in a separate. In R2, we have ZW. And we have R3 for the key, right? For this, the functional dependencies are X determine Y, Y determine P. For this, the functional dependency is Z determine W, and this is candidate key. Fine. Now, as you can see, R3 is a candidate key, so we can assume that it is in the third normal form right away. R2, which is having only one functional dependency, So it cannot find the transitive functional dependency, right? So we assume we have in the conclusion like R2 is also in third normal form. Now, what about R1? So R1, can we find, so the third step is check third normal form, in which we find out like R2 relation and R3 relation satisfy the third normal form. Now what about R1? So we'll check for R1, in which the dependencies are X determine Y and Y determine P. Let's put the transitivity rule and get the transitive functional dependence. Now check for this. Is this in the part of like key is determining some non-key? Now here in this table R1, which is the key? So X closure, we are getting X, Y, and P. So X is the key. This key is determining some non-key in transitive functional dependency. So it is violating third NF, right? It is violating third NF. It is not satisfying third NF. So R1, do not satisfy third NF. So what we have to do, this R1, which is X, Y, and P, should be split in R1, 1 and R12. So in R12, we can put this because this is creating, because of this, we are getting the issue, which is Y and P and X and Y in another table. So ultimately, what you are getting in R. So R was X, Y, Z, W, and P. Now it has been divided into number of tables. So the first table that we get here is R11, which is having the value X and Y. Then R12, where we are getting the value Y and P. Then the next one we are getting R2, which is having the value Z and W. And the last one that we are getting R3, which is having the value X and Z. Okay, so as you can see, there are some common attributes in all of the table, and we can join together and we'll get the R at last. Functional dependency here, what we have is X determine Y. Here the functional dependency is Y determine P. Here the functional dependency is Z determine W, right? So these are the functional dependency that we have, which is X determine Y, Y determine P, Z determine W that we have. And this is candidate key for what? For this particular relation. Okay, for this relation, the original relation XZ is the candidate key. So that we are putting in one table. So this R will be decomposed in 4 table: R11, R12, R2, R3.